This morning, the object of the exercise is for you to end up designing an internal assessment. Now look, they're important things because it's 26% of the marks that you're going to get for an IB in physics. So you've got the opportunity of turning up to those exams with all of those marks. There's no time constraints on you other than I will give you a deadline, but I will give you reasonable length of time to get this done. So, if you think about it carefully and set about your actual experiment carefully, there is the possibility of walking into the exams with all of the marks that you could possibly have from this aspect. And that's well worth keeping in the top of your mind all of the time. Okay, I have brought this device. What is it? Ah, no, it's a high-frequency sound generator. How could you possibly think that that was a guitar? All right, it does generate sound. How does it do it?
The string vibrates.
The string vibrates. All right. What is the difference between that and that?
This is thicker and has frequency. Yeah, the frequency.
Well, the frequency is different, yes, and you have skipped ahead. All right. So, a string has a frequency, and this is its natural resonant frequency. I could alter it. What could I change about the string?
The tension.
The tension. So that's that bit.
Yeah.
Sometimes called the machine head. Okay? So that would change it. What else?
Length.
What it's made out of?
Length.
Length. Anything else?
Diameter.
The diameter. These look quite thin. That one's definitely thicker. And you think of the difference between a double bass and a violin. Yeah? So there are some things that we could measure. Now, you mentioned the different materials that the string could be made of. Is that a thing that would be useful to pursue as an internal assessment? If not, why not? What's the sort of... Sure enough, if you change the material of the string, we'd find something out. But what are we aiming for right at the end? A graph, yeah. And can we graph material? Not easily. So, those things that you spotted lend themselves to actually being measured in some way. Yes?
For the material, instead we could measure mass.
Mass?
If it had the same length and width, but a different mass, then we could graph that.
So, same length, same thickness, but different mass. So what would that actually be? It's not just the material, but
Density.
the density of it, yeah. So perhaps that could have a bearing on it. Could be done. Shall we try tackling one of those other three things first? And what I suggest is that you now split up into 1, 2, 3, 1, 2, 3. Yeah, that just about lends itself to doing that. Threes. Yeah. And look at one of those things and come up with a scheme of what you would measure. And, now the crucial bits, I've been going over the internal assessments of year 13 again, because today is the deadline, I have to send them off, and the moderator, who's the person who looks at what I do, will send me a list of the ones that he wants to see, or she wants to see. Now, I sit there with my criteria. There's a little table, and I'll show you what it is. I'll share it with you. And in the first part, which is the design, aspect 1 is being able to identify clearly something that you are going to investigate. What aspect are you investigating? It has to be very clearly stated. And then they're identifying the variables. You know, the independent and the dependent variable. One thing depends on another. Looking at those things that you are going to control. In other words, what are you going to keep the same? And there's a part, the next bit, which says, makes an attempt to effectively control the variables. So what are you going to do to make sure that it is only what you're interested in that may change? just out of interest, can you think of a sort of sneaky thing that might change if we alter the tension in the string? If you can picture what might happen to a string, well, the length is pretty much fixed in this case, between there and there, isn't it? Can you imagine, perhaps it may make it thinner. And hang on, we just said that's one of the things that might affect the frequency. So there's the possibility that two things at once are changing. So we need to think about ways of making sure that that didn't happen. Or if it did, at least we've taken note of it. Yeah? Right. How about, well, you choose who to be with. Oh. One group, tension. One group, length. And what was the other thing?
Density.
We could have a look at density or the cross-sectional area. Right. Let's do it. I'll give you 10 minutes, is that all right?
Yeah.
Great. Go do it. And I'll just come around and show you these criteria as I have them. You call it.
Cross-sectional.
Okay.
Well, you suggested it. Yeah.
They said it first.
Okay. Tension.
Tension.
is-
Right?
Okay. It's first. Just important part of the eye game. Calling the best variable.
Yeah, go around.
Actually, everyone did the same variable.
Oh.
Yeah.
Excuse me?
I don't know much about different kinds of strings but made out of the same stuff.
Have to be the same material.
Wait, are we supposed to design?
No.
Or did you have to use a guitar? Can you add?
No, I only teach guitar strings.
we have to use the guitar?
I only put that there to be a very clear demonstration of something we can see. No, you're not obliged to use the guitar at all. So in your experimental setup, you might not find it convenient to use, I'm not suggesting you are going to find it convenient to use a guitar. It was a very convenient way of me getting all of those factors in front of you in one go.
Apologies, Mr. Phoebe.
And also, use the like this, these things. We should use these things.
Now, so you have it exactly as I have it.
And just use the bottom thing.
What I'm going to put on the board right now is the assessment rubric, as it's called. In other words, what I work from. So that you know the words, and it's getting there in the end. I think this thing's getting more and more slow. Do you?
Oh, it's not there.
It is there, but it seems to...
Fade in.
Oh, there.
I think it has something to do with the lamp life. I'm sure it was better than when it was first here. Anyway, you can see it. I'll make it a little bit bigger. If it will let me. No, oh, of course it's a PDF, so wait. 3 aspects, okay? Defining the problem and selecting the variables. So formulates a focused problem or research question and identifies the relevant variables. Now, when it comes to the marking of it, it's so easy if somebody does do exactly that and they almost leave flags lying around the place saying, here, give me the mark for this. Yeah? Not so good formulating a problem or research question that is incomplete or identifies only some of the relevant variables. And then if you don't bother to do it at all, you don't get anything. Harsh but fair. Designs a method for effectively controlling the variables. In other words, those things that you don't want to change, make jolly well sure that you don't. Yeah? So, for example, when we've done resistance of a wire, it's a jolly good idea not to make it to have the whole thing getting hotter and hotter and hotter for safety reasons amongst others. And then the third part develops a method that allows for the collection of sufficient relevant data. Okay? Now, sufficient, that means we've got to have enough points on the graph. And in the next bit, there is also the data you collect must take account of any uncertainties you have about your measurements. Okay? And that comes in the actual data collection part. But we'll just concentrate on this for the time being. So, what are you going to measure? Writing down the other things that could be measured. And how are you going to control your part of it? Then we'll get back together again, swap some ideas, and see how we can actually physically do this as an experiment in the lab. Right? Go to it, young peoples.
No, I think we Oh, it's not.
That's a hypothesis.
Oh yes.
Honestly, no, like the
And what else are you measuring? Independent variables, change, grade, percent time. Okay. So that's the thing. Now, what are you actually going to measure?
Okay.
But what's your dependent variable going to be?
Are there particular frequencies?
How might you set about doing that?
So then you just measure the sound against that. Yeah, I think so.
But wouldn't that be...
Sorting that.
Yeah, exactly. Wouldn't it leave so much...
Oh, yeah. Okay, so you want to control this before it can vibrate.
Yeah, we need to control that sound.
Sticking a finger on it might do the trick. Now, what is your dependent variable? Am I looking at?
No.
Was that meant to be in? Oh no.
What is it?
Not relevant.
Okay.
Right, what is going to be your dependent variable?
Is the dependent variable what you measure or what you're trying to find out?
Well, let's look at the word dependent. So, let's look at speed and time graph. How fast are you going? Well, it all depends on how long you've been going for. So, what are you going to measure?
Oh, so it is what we're measuring. So not what we're processing that.
What are you actually measuring in the first place? That's what we've got to do in the design bit. We've got to change something, and as a result, something else is going to change. So back to your question.
We're just going to measure the frequency.
But that's what you've just said, isn't it? In what way does changing the length of the string affect its resonant frequency? So really, you've answered your own question.
What if, for example, we were going to measure like the time it took for something to happen to find out something else? Would the dependent variable still be the time? Because that's what we're
If you're measuring the time, the dependent variable is that, and it's pretty rare for time to be a dependent variable, if you think about it, but it's not impossible. So, yes, but that's not what you put in your question.
Okay.
As in, like,
But if it was just for sake of argument,
I'm not sure.
we were going to measure the length of time it took for the string to stop vibrating.
You have the frequency right.
But then that's a different.
So
Do I
normally
have to put that
is an H, and then you can.
If you were going to do that, but at the moment we're interested in what you've given yourself, which is what is this resonant frequency.
So what would be better is if we get an acoustic guitar as in like an electric one, we can plug. It's more reliable using microphone.
Shows waves.
It's just usually dusty.
So here. So then.
Oh, it's brainstorming.
Right, team. Hello, hello.
So how does the tension meshes affect the frequency?
Mm-hmm.
Then so independent is tension, dependent is the frequency,
Yeah.
and the control length is the cross-sectional area. Also wonder how the
cross-sectional area of the
Yeah, but it's the blue thing.
gets thinner as the tension gets, the tension increases.
You're absolutely right. All we can do is a little pre-experiment to see, is this a problem or not? Does it really change so very much?
That it will affect.
Because if that is the case, yes, we've got a big problem. We've got two things changing at once. But what we could do is look at an effective way of controlling those variables. So the first thing we could do is say, all right, we'll do a little preamble experiment and see if this is something we need to worry about. And if it may turn out it's not.
It might be negligible.
And then we're trying to find a way to measure frequency.
Do we measure them against
The tuning forks. Having a reference is one way of doing things, isn't it? It may be, though, if you have a little rummage around on
We saw a
It's
solenoid
the
coil.
one that you measured yesterday?
there is that too. There are devices for measuring, quite sophisticated devices for measuring frequency, but you need to balance the simplicity of what you've suggested, and I'm not saying simplicity is a bad thing, far from it, like the simplicity of what you've suggested versus the apparent sophistication of an electronic device, which may lead us into more trouble than we wanted. Now, we do have data loggers, and they have a microphone built into them. So it could be that you want to pursue that, but it would be an idea if you came up with more than one way
Yeah.
of measuring the frequency.
Cross.
Because one of the things that we have in any measuring instrument is the idea of a calibration. In other words, how can we rely on this device that we're using?
Yeah.
So I tell you to go and measure the temperature of something. So go and get a thermometer. Come back, and I come in with 4 other thermometers. They're all saying something slightly different. Now, when it comes to the next part, which is how we deal with uncertainty, we have to have a jolly good idea of what the uncertainty is. Okay? I think I'm being summoned.
Okay.
Thanks, Christopher.
Wires probably breaking. What if they use?
Maybe a jolly good idea. Is it simple?
What if you say my friend is really good?
Setup 1 and setup 2. Oh my god.
Like, what if you?
Are you guys planning on using the tuning forks though? Are you guys planning on using the tuning
We're
forks?
gonna use it to estimate, then check whether the data logger
Wait, no.
Fair enough.
so that
reduce uncertainty by doing it with two different methods. Reduce uncertainty by using two different methods.
Always use the same plectrum.
Plectrum. Yeah, it's a plic. It's a plic. Plic.
Tension.
I have a number of plectrums.
What we could.
Well, we'll have twice as much string, yes.
Well, because if you make it four pencil with like wine, you said that it might change the diameter. So
Well, that's to do with us pulling something that is elastic, and one of the other guys looking at this whole problem with what I suggested to them was, here's a piece of experimentation you do to say, how big a problem is this? And it might be that the answer is hardly a problem at all. I thought, let's think about it. Presumably these people who make strings professional have considered this as an issue, and they might have come up with this. People have been making strings for a very long time.
Oh yeah.
They seem to be doing quite a good job. Have you sorted out in your own mind, though, that the apparatus you're going to use, what's it going to look like?
You need to find a way to control everything before you can think of it.
I think we're
I
finding
think it goes hand in hand.
to think of how to set up the string itself. But I think we really don't using an oscilloscope.
To measure frequency. Okay, right, that's fine.
But we don't know how to set up the string if we should, like, because we're changing length, attach it like to pins over ruler, and move that. But then we feel like
We feel like it's hard. It'd be hard to control the tension. Sometimes it's not because sorry, but then sometimes because if we do that, it's possible that the tension might not. It might be very low.
But you have, surely you are going to be the people who've got control over how tense the string is.
Yeah, that's why we're going to avoid it.
Well, how might you make a string tight? You pull it. Have we got anything in the lab that aids in the business of pulling something? Well, it's tricky. How do I coax this out of it? Well, there is something in that, but then there's actually something attached to a bench to it, really, and it's up. The blue thing.
I never tried training your feet.
Have a look at it. Go and have a look at it.
No, it's
Trevor, can you just stand to one side?
Why?
Get used to
It's rather aptly named, I think.
It was cool. It was
Pull.
I was thinking that when it said real, I just did not know what it is.
Possible ideas?
Oh yeah, like basically nice like E sharp on the bird. Oh my god.
Go and have a look at the tray.
Physically hold the string.
It's just behind the guitar.
yeah, there are ones there.
Are we doing it now?
Not even done.
I've got a spring. Oh, I see. Plectrum.
Let's get like each note.
The clothes peg. I don't have clothes peg, but I'm sure one could be. Yes.
Let's look at the
just putting
So you have it goes back like this.
yes,
And just put the weights on it.
and you pull it off at a certain thing. That's very repeatable and simple and surefire and yep, like it. Okay. Taking a little bit longer than I said, but never mind. Can we join back together again and talk about your corporate ideas? Go sell your experiment to somebody.
I'll go sell it. Shotgun not me.
Oh my god.
Pebbles, are you going to be spokesperson?
No, Bryson.
Right, okay.
What? He's a businessman.
Right.
This is his type of thing.
Right, give your full attention.
Yeah, I don't like our question.
Okay, so our question is how tension affects the frequency of the string. So our variables, our independent variable would be the tension of the string. We're gonna use a weight at the we're gonna use a weight here, so we can measure the tension of the string.
Yep.
Then our dependent variable would be the frequency, and we're gonna control the length of the string, the type of string we're using, the cross-sectional area, and the density of the string. So our method for collecting the data is that we're gonna use a clamp and stretch the string here and use a weight so we can measure the tension.
Yeah.
Then we use a data logger with the mic to get the frequency. We're gonna measure this against the tuning force and see whether what we hear is near what the data logger tells us.
Brilliant. Like it. That's got a lot to recommend it. Clearly, you understand what you're doing. It's got simplicity, and you've got a backup. Yes, you're going to use an electronic device to tell you definitively, once and for all, that is the frequency. But you are going to go and find out whether or not it's right. If there is some large discrepancy between the two things, one of the things you're going to have to think about is, what are you going to do? Is it something we go along with and just leave till the end of the whole process and deal with it in what's called the conclusion and evaluation? Now, sometimes having something go not entirely right in an experiment isn't a bad deal at all, because then you've got something to talk about and you've got this comparison. You say, on the one hand, this is the case, on the other hand, that is the case. And if you cast your minds back right to the beginning of the course where we talked about uncertainties and measuring things and so on, there's the idea of whether or not errors are random ones or whether they're systematic. So the sort of systematic error you might get is if somebody cut the first 2 centimetres off your ruler and you've been taking beautiful measurements, it's just you're missing 2 centimetres every time. It could be that there's a discrepancy between your data logger and these things of a certain amount. And that would be something to talk about. Next, let's see.
Okay, so